Hi, students. Dr. Madewell here, and today we're going to talk about independent samples t-tests. Let me share my screen with you. When we talk about independent samples t-tests or non-repeated samples t-tests, we're interested in two independent groups of people and comparing them on some kind of an outcome variable. So where we have been, what I also want you to do is to read about a one sample t-test today and this week. And one sample t-tests are where we compare our data to population data. Population data is very difficult to get unless if you're, let's say, a criminal justice graduate and you work at a prison. You might have population data from your whole population of prisoners, okay? But in behavioral sciences and in psychology, oftentimes a researcher will produce a manual that will have population parameters. But go ahead and read about one sample t-test. And this week, your homework and your data analysis quiz 2 is all over independent samples t-tests. So let's start focusing on that. Typically, we're interested in the means of two different groups of people, and we want them to be independent for this type of statistical analysis. So oftentimes we're interested in a control group versus a treatment group. If we want to see, is this treatment working better than, say, a control group that gets a sugar pill? Other times, our research topics might be comparing men to women. Or, like we talked about in previous lectures, cat lovers versus dog lovers. Now, for this next topic, or for independent samples t-tests, we're going to compare two sets of data for these two different groups. So that's why it's called an independent samples t-test or non-repeated samples t-test. Those are both comparable. Oh boy, I have all kinds of fun. Okay, let's talk about key concepts for this chapter. We're going to talk about experimental versus control quite a bit. When we talk about an experimental group versus our control group is sometimes also called the placebo group. A placebo means that we don't give them anything. Okay, a placebo is maybe we have our 50 participants who are receiving this new special drug we've developed, and we give it to them every morning. Those that are in the placebo group don't know that they're in the placebo group, so they're still going to come to us and get a cup, and it's going to have a little sugar pill in it, okay? Because we really want them to think they're getting the treatment so we can understand those psychosomatic outcomes as well. Okay, because we all know if we think we're getting a treatment, sometimes that can be in itself a treatment, right? So we would diagram our two groups of people as such, and I'd like you to do this on your weekly notes. We want a rectangular box that could have our drug group, okay, that's getting our experimental drug. And the other box would be the group of people that is getting our placebo or our control group. Okay, we're going to use those terms throughout this semester interchangeably. Okay, placebo or control would be the same. Our drug or our treatment group would also be synonymous terms. So go ahead and draw that out on your handwritten notes. When we talk about our two conditions, that's also what we call our independent variable. The book describes that as the condition you manipulate. Okay, so if we have 50 people in a trial and they all come to us, and half of them we give the new type of antidepressant, and the other half we give a sugar pill, and they don't know who's getting what, That would be our independent variable. As the researcher giving out the different pills, that's us manipulating outcomes for those individuals. The next variable of interest is our dependent variable, and that's our outcome that we measure. In this example, maybe we could talk about concentration. So if we give them our new drug versus the sugar pill, who has better concentration ability? When we have an outcome variable or a dependent variable, we draw that out as an oval. And so our independent variables or our groups, we make them in rectangles. Our outcome variables are in the shape of an oval in our models. So let's put it all together. When we draw out our independent samples t-test statistical analysis plan, we would have our two boxes representing our two distinct different groups of people. So maybe we have 25 in the drug group and 25 people in this placebo group, randomly assigned. And then what we want to do is measure all of the 50 participants' concentration ability and see who's doing better, who has a higher mean score. Make sure to draw this on your handwritten notes, and it would be great for your cheat sheet too at the end of this for your final. If you need more time, please stop the video, and when you're caught up, hit play. Now, let's move on to the independent samples t-test formula. This is a big one, okay? Our t-test is going to evaluate x1 with a bar over it, x bar 1, that means the mean for group 1 minus the mean for group 2. And this is really helpful because we want to know what was the mean score of concentration for those who got our new experimental drug, subtracted by minus the group of people who got the placebo pill. Who was doing better? Okay, that would be our numerator. When we subtract then our mu of 1 minus mu of 2, our mu of 1 would be our population mean for group 1 and our population mean for group 2. In this realm, we just cross through those because we these are hypothesized mu's, which don't exist, and we don't have those because this is a new experimental drug, so we would just cross this out. And next, for our denominator, we would want to calculate our standardized error from mean of group 1 minus mean of group 2. Now, this is our formula. It's called pooled variance. We're going to move on past that because we're not going to hand calculate. We're going to use SPSS this semester. But keep this just for notes for future reference. Okay. In grad school, you might have faculty teach you, ask you to calculate this. I'm going to hit the next slide. Now, when we have two comparison groups, two different people, we have our experimental group and our control group. That means that we have a ton of notation. Double the notation. It can make it extra confusing. So please make sure to write this slide down in your handwritten notes, what we want to do and what I want you to know. This would make a great final exam matching question. If we have n, little n sub 1, that would be the number of scores in your first group. So in the experimental the experimental drug group. N sub 2 would be the number of people that were in our placebo treatment. Okay. X bar sub 1 would be the mean for the first group. X bar sub 2 would be the mean for the second group. Sum of SS1. So when we were doing standard deviation, remember calculating that on the midterm, you won't be hand calculating this on the final or the homework, but we're just going to review over it. But sum of squares 1, we're going to have two of those now. We're going to have sum of squares for our experimental drug group and the sum of squares for our control group. All right, so what does this mean for us? Simple experiments most commonly involve two groups of people, okay? And our goal is to evaluate their mean difference. Okay. So really circle this mean difference right here. We really want to evaluate the mean difference between the groups. And then we really care about the populations, but it's too expensive to collect data from everybody in the population, and we can't expose everybody in the population to our new experimental drug, can we? That's unethical. So we're going to pick these 25 people who give consent to volunteer to try our new drug. But if we can find a mean difference, then what we can do is publish our findings and generalize our data onto the bigger population and say that this drug could help your concentration increase, right? Take this drug, it'll help you, etc. Okay. Now we have several assumptions. And when we're talking about assumptions of our hypothesis testing for an independent samples t-test, what we know before the population, we could get the mu, the population mean. We can get that. Okay, what's your concentration rate? Maybe it's 100 items you could concentrate on a day. I don't know, that seems kind of like a lot, but we're just going to say that's what it is. And we could say our sigma, or our standard deviation for the population, is 15. Well, if we give our treatment, here's our treatment, and we give our little new pill, what we don't know, we can estimate, and I think our sigma should still be 15. But what we don't know and what we hope is that we get that mean difference. So if they were only focusing on 100 things, maybe now they're focusing on 120 or more things. Okay. So we want to calculate for that. All right. Well, that ends out our first lecture for this independent samples t-test understanding. I will want you to follow along with the textbook. Make sure you're reading and make sure your notes are clear and legible. And I'll see you for your next video. Thank you.